between a daylight picture and a nighttime picture, because all the pictures of the Russian ships were taken at night. And so that turned out to be the principal component, like what time of day is it, as opposed to anything about the shape of it. And so you really want to be able to build an explainable model that you can explain to somebody. This is a cat because it has fur, whiskers, and claws, and it also has this kind of feature. I don't have a name for it, kind of thing. So you'll have things like that. However, we need to reach beyond second wave. So self-driving cars, they need to be able to build up pictures of what's going on that they can start doing reasoning with, and we've already seen that second wave stuff isn't good at reasoning. Think about this exchange. I'm allergic to apples. Don't eat the cake. Why not? What's your guess? Because the cake's got apples. I mean, but do you realize how subtle that conversation is? And how could you train a system to come up with that level of subtlety? It seems really high. We're interested, particularly in dangerous parts of the world, being able to have ISR stands for intelligence, surveillance, and reconnaissance, to be able to see, is there a terrorist activity taking place in certain things? Or this is from a movie, of course, college and colleague and team systems. I mean, as I say, when I'm using Siri, there'll be things like I'll say, you know, where's the nearest gas station? And it will come up with, here's a list of gas stations, and I want to say, which one am I going to pass anyway? You know, and you can't have that conversation with Siri. I want to be able to have a back and forth. And that requires something different that's not present in the second wave systems. What it requires is something called a contextual model. Think about that car thing. The car needs to have a notion of that's the thing called a road. That's a pedestrian. That's a cyclist. Those kind of concepts turn out to be really valuable concepts. And you need to have your second wave look at the outside world, do the perceiving and the learning that it's really good at, build those models that the other parts of AI, more like first wave kind of techniques, can combine by doing reasoning and maybe even abstracting on. And so if we start getting good at these third wave things, they will still be strong at perceiving and learning because they'll have that from the second wave, but they'll also have reasoning. So I've got a puzzle for you. I know we're close to our time here. I've got a puzzle for you. I'm going to put up an image, and don't call out when you realize what this image is, but you start looking at this image and you think maybe it's a map of, you know, where is it? And you're looking at this image and you're trying to make sense of this image. If you see what it is, put your hand up. Okay, a couple of people. Keep looking, everyone. I'll give you a clue. It's an animal. And here's one of its eyes. Who has it? Put your hand up. A few more of you. Here's the other one of its eyes. And this is its nose coming down to the front of the... What's going on right in this moment? So what is it?
It's a cow.
It's a cow. Okay, and so here's the back of the cow, here's its eyes, here's its nose, its nostrils, and so on. But each time I gave you a little bit more, your brain was taking that information, building a model and saying, can I see some animal in that? Like, can I make any sense of that as an animal? Can I make any sense of that being the eye? And so on. It turns out that your brain has more neurons coming from the modeling part of your brain to your eyes than the other way around. Traditionally, we think that your eyes feed into the back and that it's process it, deliver the result. Not true. Turns out that that's not the way the brain works at all. They do a bunch of processing, like here's a line, those kinds of things. And then your brain says, I'm expecting to see a car or a cow or a person or a house or, you know, a million different things. And this is what it would look like if it was the cow. This is what it would look like if it's a house. And oh, the cow is starting to look good. And it's that kind of matching that's taking place between them. So your brain works on the notion of a model. What is your brain expecting to see? And then you can start to see it in the image. There's not enough information in the image itself to be able to construct it. This happens in sentences as well. A large ball crashed through the table because it was made of styrofoam. What's made of styrofoam? A large ball crashed through the table because it was made of styrofoam. What's made of styrofoam? The table. Large ball crashed through the table because it was made of steel. What's made of steel? The ball. You use your knowledge of circumstance to make sense of a sentence. You use the model that you have of the real world to make sense of the sentence. You can't just use the sentence itself to make sense of it. So it turns out that there's a whole area called probabilistic programming, which turns out you could use probability theory, another part of mathematics. Yay, who's done probability? A few of you, maybe? Yep, good. Probability. So you might start doing probabilistic stuff, which say, when I write digits, there's between 1 and 4 strokes, and maybe lots of them are 1, and then a few of them are 2, and almost none of them are 4. You might also talk about when you're doing a hand movement, it follows these kinds of curves. Like it doesn't go dot, 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 or anything like that. There's certain shapes that we do. They're also given that if somebody's doing a curve, how does that curve sort of shift over time? So you build a model like that, a probabilistic model. And then you just show it an example. Here's a 0, here's a 1, here's a 2, here's a 3, here's a 4, and so on. And then when you give it something like this scroll here, it will take this seed model along with this data as to sort of canonical examples, and it will combine those things, and it will say, if it was a 9, it would have been built this way. If it was a 4, it would have been built this way. Which of those is actually closest to the thing that I see? So what's astonishing about this is the way that it impacts training. A neural net, like that one that we showed for hand digits, you need to train it on about 50,000 cases, 100,000 cases, something like that. Now, I'm a patient guy, but when my son was a kid, if I had to show him the same thing 50,000 times, I would start to find it a little tedious. And so if I had a robot butler in my house, and I had to show it how to make tea 50,000 times, again, I would have kicked it out long ago. What's interesting about this is if you have the seed model, you only need to show it something once or twice or perhaps 3 times, and it gets it. It's the seed model gives enough of the structure to what the underlying statistical shape is that it's able to do something useful. So this is the sort of contextual model that you provide information in conjunction with, and then you get something out. So it's an early example for third wave. Here's another cool thing that we did. This built on a DARPA project, and then the Gates Foundation funded it to study malnutrition in Africa. It turns out that if you've got a kid who's malnourished, like severely malnourished, and you get to them and you want to rescue them, you can't just feed them. Their body is not in the right state that it can accept food. And so there's a very careful way that you need to go through. And so what they did was that they wanted to build a model which said, in this situation, this is what you need to do with this particular child or this particular adult in order to bring them to health. How do you build that model? The system read 20,000 research papers, and from each of these research papers extracted a few facts and put those facts together to build this rich model of what's underneath. And so it did natural language understanding, fact extraction, in order to build individual facts, to build this contextual model that it's then able to use and apply in different situations. So absolutely fascinating. So final thing, 3 waves. There was the handcrafted knowledge, There's statistical learning, which is the big wow AI that we're in at the moment, but with the limitations that we've just seen. And we're starting to see early examples in some of the self-driving cars. The reason they're not working yet is because this hasn't yet been taken seriously enough. As we'll start getting richer things that will be able to have a context, Siri will be able to have a conversation because it will know where we are in the conversation. It will have a model of the knowledge that is being transferred. So just because something is first wave doesn't mean it's old and boring. There's great applications of first wave. My whole company does first wave stuff in the mathematical logic and formal methods. Second wave is amazingly effective, but it has fundamental limitations. Third wave, just beginning, and even though I was running national scale research programs, I can tell you we don't see it very clearly yet. We don't know what some of the fundamental things are. But you're a math club. Every one of these waves, there's fundamental applications of mathematics. So there's a big impact. Some mathematicians just like to do math because it's math, and others of us like to do it because we want to see it have application in places. And so lots of opportunity. So questions, thoughts? Yeah.
So the statistical learning, I think there was what they call classical AI. Would you say that?
That's what I'm calling first wave. Yeah.
Okay. You compared second wave AI to insectoid intelligence.
To what?
Insect intelligence. Insect intelligence, because some people, I think MIT, that we compare it to insects.
Yeah, so I haven't studied insects, so I hesitate to answer that. I mean, I genuinely don't know what the neural structure of insects are like or their behaviors. But it wouldn't surprise me. I suspect they don't do very much reasoning.
Yeah.
Yeah. Yeah.
With the third one, we're saying that it's not taken seriously yet?
I think that industry still has so many ways that it can take advantage of second wave, that's all absorbing and encompassing. And third wave is showing up more in research labs and universities and things like that to understand some of the fundamental questions. We're not yet ready to build large-scale third wave systems because we don't know their structures very well.
Well, roughly, if you were to guess, how long, how many more years until people could understand that more?
Yeah. So one of my friends at DARPA used to quote this quote from someone else, and I don't know who it's from, which is, the future is already here. It's just not very spread. It's not spread widely yet. So there are already spots where it's being used. You're asking now a social question as to, and sort of economic question, how long will it be before it's widespread? And I don't have any tools for answering that kind of question.
Do we know any limitations to the contextual model yet?
I think we haven't defined it enough for that question yet to make sense.
But for now, could we say any limitations so far, as of now? Even though it's not concrete?
So it may be that the big challenge, the stunning thing about all of you is you were gibbering idiots, and now you're not. Me too. Like, how did that happen? To what extent did we have sort of contextual structures built in? And to what extent, I mean, is there any limit as to what a human being can learn or think? Or I don't know the answer to that. If you have a very simple notion of a context, then there will be limits on what it can do. If you have a rich notion of a context that can adapt and grow, then you may get to human levels. I don't know. In individual capabilities, we already know we can exceed human levels, as we can with strength. I mean, mechanical diggers are a lot stronger than I am, and that doesn't scare us. And AlphaGo is a lot better at Go than I am, and that doesn't scare me because I get to do things that AlphaGo doesn't. So I'm actually not worried about the AIs taking over, at least not for foreseeable future.
In that vein, how much do you use psychology in this sort of work?
So, so there are psychologists now are front and center, as well as linguists and computational linguists and things like that. So a lot of what we used to think of as soft sciences or even the arts turn out to be very relevant as we're looking at tuning this. There's a lot that can be done without psychology, but if you're wanting to develop a system that actively interacts with people, then you better know your subject, and that probably means you better know psychology, or have people on your team that know psychology.
In the past, you've talked about like human consciousness related to like machine consciousness.
Yeah.
Do you want to?
Sure, let me expand just a little bit on the comment that I made at the start. Just because we